You've probably heard the phrase growing exponentially thrown around all the time, right? It's used to describe pretty much anything that's getting big really fast. But what does it actually mean? From a math perspective, it's a concept that's way more powerful and way more specific than you might think. So let's break it down.
Yeah, when we say something is growing exponentially, our brains usually just translate that to happening very, very quickly. But you know what? That's really only half the story. The real definition is much more precise. And frankly, it's a whole lot more interesting. It's a special kind of fast growth, and it all boils down to one simple fundamental difference.
Okay, so the entire secret to understanding exponential growth is right here. It's about a single choice. Are you adding or are you multiplying? The difference between adding a fixed number over and over again versus multiplying by a percentage over and over, well, that little distinction changes everything.
All right, let's make this super clear with a quick scenario. Imagine two companies, Company A and Company B. They both start with exactly 100 stores. Now, Company A grows in a straight line. We call that linear growth. It adds a flat 50 stores year in, year out. But Company B grows exponentially. It increases its total number of stores by 50% each year.
Now look at how they start out. After year one, they're dead even. Both have 150 stores. You'd think there's no big difference. But this is where the magic of compounding starts to kick in for Company B. See, while Company A just tacks on another 50, Company B calculates 50% of its new, bigger total. And that small difference creates a huge gap, and it does it fast. By year 4, Company B has already blown past 500 stores, while Company A is just chugging along at 300.
And after just 5 years, wow, the difference is absolutely staggering. Company A has a very respectable 350 stores. Can't argue with that. But Company B, it has almost 760. That's more than double. This right here is the raw power of percentages. Over time, exponential growth doesn't just beat linear growth, it completely and totally dwarfs it. That multiplying engine is just playing a different sport.
So what's actually making this engine tick? Let's pop the hood and take a look at the actual mathematical formula that's driving this incredible acceleration.
So this is it. This is the general form of an exponential function. It might look a little intimidating, but the most important thing to see is where that little x is. In a straight line, linear function, the x is down on the main line. But here, it's up in the exponent. That's the secret sauce. That's what tells the function to multiply its base by itself over and over and over again.
Think of it this way. Each part of this formula has a really simple job. A is just your starting point. In our example, that's the 100 stores. X is just time, the number of years that pass. And B is the growth factor. Now, if you're growing by 50%, you're keeping 100% of what you have and adding 50% more. So your multiplier is 1.5. And that's your B. Simple as that.
You know, that little letter B is basically the hero or the villain of the story. If B is anything bigger than 1, you get that famous J-curve of explosive growth. But, and this is so cool, if B is a fraction, something between 0 and 1, the whole thing works in reverse. You get exponential decay. The exact same math that models a booming business can also model how a radioactive element fades away.
Okay, that's the math. But where does this stuff actually show up in the real world? Well, it turns out this is not just some theoretical concept from a textbook. It's a fundamental pattern that shapes our money, our planet, and our lives.
Let's take population growth. Back in 2013, India's population was about 1.25 billion people, and it was growing at roughly 1.2% a year. Using our model, we can plug those numbers right in. The initial value A is 1.25 billion, and the growth factor B is 1.012. And just like that, you can make a pretty solid prediction that by 2031, the population could hit over 1.5 billion people.
But maybe the best and most personal example for all of us is in our own bank accounts. It's a little thing called compound interest. The whole idea, like this quote says, is that you earn interest not just on the money you first put in, but on the interest you've already earned. It's the exact same principle as Company B, but it's happening to your wallet.
And yep, here's its formula. Now, I know it looks a little more complicated, but trust me, it's the exact same idea we just learned. P is your starting money, just like A. The stuff in the parentheses is just a fancier way of writing our growth factor B. And NT up in the exponent, that's just time, or our X. And just look at what's happening here. If you invest $1,000 at a 10% interest rate,
The more often you compound it, going from once a year to quarterly to monthly to daily, the more money you make. It's not a huge jump each time, but every single step up in frequency gives your growth a little extra kick.
So, this begs an amazing question, right? Where does this end? What's the logical conclusion? What if you could compound your interest every minute, or every second, or at every single tiny infinitesimal moment in time? Is there a limit? Is there a speed limit to how fast your money can grow?
Well, it turns out there is a limit. And that limit happens to be one of the most important, most fundamental, and kind of mysterious numbers in all of math.
So mathematicians started wondering about this. They ran a thought experiment. What if you invested just $1 for 1 year at a 100% interest rate, and you just kept increasing the compounding frequency, n, as n gets ridiculously large, daily, per minute, per second? Look what happens. The final amount doesn't just shoot off to infinity. No, it starts to settle down. It gets closer and closer and closer to one specific value. You can see it stabilizing right there at the bottom.
And that special number is e. It's an irrational number, kind of like pi, that's roughly 2.718. It's called Euler's number, and it is the natural base for all growth in the universe. It's the absolute maximum, the universal speed limit for any process that grows and compounds continuously. And what that gives us is this absolutely beautiful, simple formula. It's often just called the PERT formula. It's your principal amount times e raised to the rate times time. This is it. This is the elegant mathematical key to the fastest possible exponential growth.
All right, let's wrap this all up. After all that, what's the one big thing you absolutely need to remember?
It all comes back to this one final showdown. Linear growth is steady, it's predictable because you're just adding a fixed amount. But exponential growth, it's explosive because you are multiplying by a percentage. And that simple act of multiplying on a base that's always getting bigger is the compounding engine that creates such mind-blowing results over time. So to sum it all up, remember, exponential doesn't just mean fast. It means growth by a constant percentage. That compounding effect is why it will always crush linear growth in the long run. This pattern isn't just in textbooks, it's everywhere, from your savings to how populations grow. And finally, that amazing number e is nature's speed limit for growth. And that really leaves us with a final challenge for you. Now that you truly see the incredible power of compounding, take a look around your own world. What in your life, your skills, your savings, your knowledge, what could you start growing, not just by adding to it, but by multiplying it?